Hello and welcome to my next video. Today we will be going over Boolean logic. Basically with Boolean you can only get two results, and that is either true or false. There is, I'd say, three or more like four operators in Boolean. The first one is going to be OR. You might see this as a plus sign, or the double such that symbols. And usually we will denote the variables as P and Q, and when you go about evaluating, they will be A and B. So let's say we're going to OR them. So let's say we have P as true, Q as true, P as true, Q as false, P as false, Q as true, and P as false and Q as false. And then we see what values we get when we OR them. So if we get true and true and we OR them, the result is going to be true. If we go true and false, the result is going to be true. If we go false and true, or false or true, then the result is going to be true. And if we do false or false, the result is going to be false. So with OR, the key thing is as long as one's true, or as long as one variable is true, the whole answer is true. The whole thing is true. Now let's try AND. So AND may be represented as AND, or a multiplication symbol, or two ampersands. So again, if we do our truth table, P, Q, and then we AND it, true, true, false, false, true, false, true, false. So true and true gives you true. True and false gives you false. False and true gives you false. And false and false gives you false. So the key thing about AND is that everything has to be true to be true. And the last major operator is called exclusive OR. Right here. Exclusive OR, written as XOR. You may see it as a circle with a plus sign in it, or the caret symbol. And again, if we do our truth table and we OR it, true, true, false, false, true, false, true, false. True exclusive or true gives you false. True exclusive or false gives you true. False exclusive or true gives you true. And false exclusive or false gives you false. So for exclusive OR, they have to be opposites. Have to be opposites to be true. So again, with OR, when you OR in something, as long as one thing is true, the whole thing is true. For AND, they all have to be true, and for exclusive OR, they need to be opposites to be true. The last symbol is the not, which may be represented as a horizontal line or an exclamation mark. And what not does is it just flips the result. So if you get not true, that's going to equal to false. Or if you get not false, it's going to equal to true. If you not an or, like if you're not an or, we'll see more of this later, because in one of the questions in computer science, it's gonna have to be simplifying Boolean, like a Boolean expression, and sometimes you might see not or, but this is just basically a De Morgan's law, which I'll go over I think next, and this is gonna be an and. Oh, I should done. And if you're not an and, you get an or. And if you're not an exclusive or, you're just gonna get a not exclusive or. And basically what that means is now they either have to be true or false and false. They have to be the same result. Then now I'm gonna go over all the Boolean identities, and you gotta pay really close attention to this. I'll put this right here. I'll put this in the frame. Okay, so the first identity is a plus a equals what? So what does a plus a equal to? Well, a could be anything. It could be true, it could be false. So let's say that a was true. That means true or true gives you what? True, right? As long as one thing is true, the whole thing is true. If it's false, false or false gives you false, right? They're both false. If everything's false in an or, it's going to be false. As long as one thing is true, the whole thing's going to be true. But because they're the same variable, basically, it's going to be whatever the variable is. So a plus a equals to a. What if we add a times a? So let's say a was true again. True and true gives you true. Remember, everything has to be true, and they're both true. If it was false, false and false gives you false. As long as one thing is false, the whole thing is false, right? So a times a gives you a. What if we had a plus b? Well, a is one variable and b is another variable. We can't really determine what values they are, but we do know that you can just flip it using the commutative law. Oops. A plus b equals b plus a. Let's say we had a times b. That could also be written as b times a. Again, the commutative law. Oh my god. And usually, when we write in the simplified Boolean expressions, we usually write the multiplication as like AB or BA. We don't really put the multiplication sign between them. I don't know. It's just something that I guess we do. Next thing is just the associative law. A plus B plus C equals A plus B plus C. So when you're evaluating and you think it'll be easier to evaluate this part than that part, you could just use the associative law. Same thing works with multiplication. I'm going to keep on going down. Let's see. Oops. A times B plus C. It's just using the distributive law. You're going to get A times B plus A times C. And then if you had A plus B times C, you're going to get A plus B times A times C. A plus C. Oh my god. Sorry, that's my dog. How do we get this? Well, if we use the formal method, A times A times C, B times A, and B times C. Right? We said that A times A gives me A, And using law of absorption, which we'll talk about that. Actually, it's coming up. You can basically absorb this A, C, and this A and B, and you're gonna be left with B and C. What if we had A plus 1? Well, what is 1? Well, 1 is true. So let's say A was true. True or true gives you true. Let's say it was false. False or true still gives you true. As long as one thing is true, the whole thing is true. So the answer is going to be true. And if we had A times 0, let's say it was true. True and false. Well, 0 is false. So true and false gives you false. And let's say it was false. False and false still gives you false. So the answer is going to be 0 or false. And these are your this is union and this is intersection. And then we get into law of absorption. Law of absorption is pretty cool, and it's the most fun to do because you just like eliminate stuff like we did right here. So let's say we had A times A plus B. But when we do distributive property, we get AA and AB. A times A is A, so it's going to be A plus AB. Now, if you have a single variable and like you're ORing it, and it has another variable, like, how to say it? Let's say you have, again, like in this case, we have A, but I also see that A is in this A and B here too, and we're ORing them, so we can just eliminate them. And we get A. It's basically, if you have a lone variable and you have that same variable with another variable, like you're adding them, you can absorb that. I'll get more into detail here too. Let's see, we had A times A plus B plus C plus D dot dot dot. So that's going to be AA, AB, AC, AD, dot dot dot. Well, AA is A, and all these get absorbed by this single A because all of them share an A, right? So in here inside this parentheses, as long as there's an A there, like it doesn't have to necessarily be an A too, it can be a B. Let's say there was a B here. Because there's a B here too, the B is going to absorb everything. So basically, with law of absorption, as long as there's a single, like a lone variable, and you're ORing it to the same variable that's being ANDed by something, you can absorb it. It's not that difficult. It's really, really cool. Just know that, like in here, we had A plus AB plus AC plus AD. This A, as long as if you see an A anywhere, just absorb it. Unless just absorb it. Let's say you had 8 times 1. 8 times 1. So let's say it was true. True and true gives you true, right? Let's say it was false. False and true gives you false. Notice how we both get the same answer as what was in our variable. Again, if A was true, true and true gives you true, false and true gives you false. So A times 1, or A and true, gives you A itself. And let's hear A plus 0. True or false gives you true, and false or false gives you false. So it's still going to be A as well. And now we get into nots. So let's say you had not A. Then your answer is just going to be simply, well, not A. That's the symmetric law. But that's not what I'm trying to get at. What I'm trying to get at is whatever your A is, just flip the result. So if it was A was true, now it's going to be false. If A was false, it's going to be true. So what if you had a double negative on A? Well, the two nots cancel each other and you get A by itself. Because let's say A was true, not true is false, and not false is true, which is what A is. Again, let's say we had A plus not A. What do you get? You get 1, or true. How do you get true? Well, if A was true, and you're ORing it to something, well, we know that A is true to begin with, so the whole thing's true. We didn't have to look at this. And that's what the computers do. It's called short circuiting. But let's say it was false. False, or we now need to go here. This is not A, so it's not false, it's true. So false or true gives you true. So A or not A gives you true. And what if you had A times not A? Well, true and false gives you false and true gives you false. So the answer is going to be false. Now we get into De Morgan's law, and this is very important because you're going to be doing a lot of De Morgan's law when you simplify Boolean expressions in the example questions. And I'll go over some as an example. Let's see, we had not A plus B. As in A plus B, the whole thing is being knotted, right? We using the De Morgan's law, just split it up like in lines. Each operator and operand. So this is going to be not A. So we go A first, and then we go here. Not or is and not B is not B. So that would be your answer. And if we had the same thing, but instead we're multiplying them, or we're anding them, first we go here. This is not A. If you're nodding an and, it's going to be an or, and not B is just not B. And then we get into exclusive OR. And basically the main thing for exclusive OR is to memorize this. Not A, B, plus A, not B, equals A, exclusive OR B. You have to memorize this. This is very important. This comes out a lot. You have to know that basically the way I memorize this is the first one is being knotted and the last one is being knotted. The rest that are in the inside aren't. And let's say you want to do not, it's not and, it's exclusive OR, my bad. Or in this case, A exclusive nor B. Then it would be just simply the opposite. It would be AB plus A naught times B naught. This you also have to memorize true, but you could just not everything, like not the whole thing, and you still get the answer. And then we get into this cool law that you have to memorize too. It has to come out a couple times, and if you don't know how to do it, well, you're just gonna get it wrong. It's called the law of the disappearing opposite. Basically, if you have A plus A naught B, this A naught, because it's opposite of this, you just throw it away and it becomes A plus B, right? If it was not A plus AB, this A gets removed and it just becomes not A plus B. And then you can also do foiling too. Like if you have A plus B times C plus D, you foil, you get AC plus AD plus BC plus BAD, and that's all you can do. So you can also foil using Boolean as well. The next thing, and please memorize all of this. This is going to be in the Google Classroom. It's also on the U.I.L website for computer science, so you should check it out. It's very important because I really think that Boolean is easy as long as you actually practice Boolean. It's very, very easy, at least in my opinion. Then I'm going to go over the logic gates for Boolean, and these are very easy to get right during the test. Basically, just kind of weird. Let me put this in the frame first before I begin. you want to represent a variable using like electronic symbols, let's say you want to represent A, then we would have to use a triangle, right? We would call this triangle A, and this would go into an operator if we wanted to. But what if we wanted to represent not A? Well, we still write the triangle, but then we have a little circle. This circle just means not. And this is A. Now if we want to represent or, I actually think of it as it has a curve. So let's say you want to or A and B, then this would be A or B. If you want to and something, it's going to be flat. A, B, so it's going to be A times B. If you want to exclusive or something, let's say A exclusive or B, or maybe I should have done this. I think of it as or. You do the or symbol, and then you write another curve, and that's how you know it's exclusive or. Exclusive nor is the same thing. For exclusive nor is a not of exclusive or. No, it's not. My bad. Well, it is, but okay, never mind. Nor. I'm gonna go over nor. Nor is just not or. And how do we do not or? Where we know or is the curve, right? And then we just put a circle like that. So now if we have A and B, it's gonna be A or B, and then the whole thing gets knotted. If we want to do NAND, which is not and, it's gonna be the same, and, but with the circle at the very end. A, B. So that's gonna be A times B, and the whole thing gets knotted. If you want to do exclusive nor, oops. So A exclusive or B, the whole thing knotted. We know or it's just two curves, 1, 2, right, with a circle. A, B. And that's pretty much it for logic gates. So for example, this may be confusing, but let's say we had this. Let's be A, B, and C. So what is this? Well, we know this is and. So it's going to be A times B, right? And now we're going to or, because this is or, to C. Now, I like to really take note of parentheses, because whatever this value we get, the result, is what's going to be ORed. It's so I really like to put parentheses, because it's this value is getting ORed with C, the value of C. So I'm a really strong advocate for parentheses. Let's do another example, one more. If we had this, so this is and, right? And we're gonna have A, but A is being knotted. So it's gonna be not A and B. And the result is gonna go into this or, right? Or it to C. But the C is being, the or is being knotted, so everything gets knotted. And yep, that's just simple logic gates. I think logic gates are the easiest in my opinion. And now let's go over some examples, and then we'll be done. let's we had Boolean P equal to true, Boolean Q to false. We want to print not P or Q. So basically, you can do it two ways. You could either evaluate the inside first and then not it, or use the Morgan's law. I would have just evaluated the inside. So we get true or, because the double straight lines is or. So P is true, Q is false. True or false is true. Because one thing was true, the whole thing is true. And then we're noting it. So not true is false. So the answer is going to be false. That's your answer. Let's say we had this. This may look hard, but it's not. First is do this part. We get this is exclusive OR because it has two curves, right? So it's going to be A exclusive OR, and B is being knotted, so it's not B, right? And then put the parentheses in because this value goes into this AND because it's a straight line, and C or D, right? Because of the one curve that makes it OR, but the OR is being knotted, so the whole thing gets knotted, and that's your answer. If you don't see in parentheses, that's still your answer. It's weird. Well, at least in the question that I got it from. Anyways, another example. This one I'm trying to talk about using, it's a lot of De Morgan's law, but it's very easy. Okay, let's see, we had straight line. We had A or B times C, whole thing's being knotted, times A times B times C, the whole thing's being knotted. So let's go one by one. This is not A. Not or is and. Not and a not cancel each other out. So it's B times C. This becomes an or. Not and is or. And then the not and not, the double not cancel each other's out. So it's just going to be left with A times B times C. Then we rewrite it this way. Not A, B, C plus A, B, C. Now, from here, you might not know what to do, but, oh, my bad. There was actually supposed to be a not on top of the C. So now from here, we see well, what variable is in common in both of them, and that is the B. So we're going to factor out a B. Actually, and we're left with not A, not C, plus A, C. Well, we have two knots, and we're ORing them with two variables that aren't being knotted, and that is just exclusive NOR. So this becomes B times A exclusive NOR C. That's your answer. Another question could be, you may ask this one. How many ordered triplets make this false? And they give you the expression, not A plus B times C. So let's simplify it first. Not becomes, they cancel each other out, so you get an A. Not or is and this whole thing's being knotted, so it's not B or not C, right? And now from here, it's just how to say it, using your knowledge of like ors and ands and stuff, you can get this question right like pretty fast. So we know that we're being anded, we're anding A and not B, and then we're oring not C. But the thing is, if A is false, then the whole thing, well, at least in this case, the whole thing's gonna be false. How many Boolean expressions make this false? So let's see if we said that A was false. Well, it doesn't matter if B is, because regardless of whether B is false or true, the answer is still going to be false. So let's say B is false, right? What about C? Well, in order to make this false, C has to be false. So we can say C has to be true. Why did that be true? Because not true is false. And actually, I forgot to mention this, but the order of precedence for Boolean is and then exclusive or, and then or. So we're gonna and this first, and then we're gonna go exclusive or. So now we got that. Well, let's say A was still false again. Let's make B true this time. Well, C all still has to be true because we want this to be false, right? Now, let's say A was true. Well, we need B to be true. Why do we need to be true? Because not true is false, and anything and false will be false. And now we still need C to be true because we want the whole thing to be false. We can also have 0, 1, 0, 0. Let's see. True, no. The answer was 5, but how? No way, the answer is 30. I'm sorry guys, just wait. That's weird. The answer is 5, but I think the answer is 5. I didn't even check. Just damn it. Oh, there's no time. Never mind. Forget about this question. Oh my god, I'm sorry guys. Let's see. Okay, what if we had this? A times not B plus not C plus A times B or C not. Well, we use the distributive property A not B plus A not C plus and then we use De Morgan's law real quick. This becomes A times not B and not C. So then this becomes A not B plus A not C plus A not B not C. We see all of them have an A. So then it becomes A times not B plus not C plus not B times not C, right? This is a little multiplication sign there. Then we could use law of absorption, which are with either the not B or the not C. Either one of them absorbs this guy. So then it becomes A times not B plus not C. And that's your answer. Okay, this one's a better one. How many pairs make this false? Pairs make this false. And it's not A plus B, which becomes not cancels, not or, and then not B. So remember, as long as one thing is false, the whole thing's false. And now we need to flip it. So if, let's say A was true, then we need B to be true also, because not true is false. So the answer will be 3. Okay, well, I still got more examples. Let's see. Yeah, let me do this one. Yeah, separate them. Let's say we had B times A plus B times C plus A times C plus A times B times C plus B. Well, we have this lone B here, so it's going to absorb anything that also has a B with it. So it's going to absorb this guy, and this guy. So the answer is just A times C plus B. And then we'll do one more example, and then that'll be it. Yeah. Piece of paper. So let's say we had A times B plus A plus B. So not A or not B. Multiplication sign, not cancels everything out. So now we put parentheses, because without the parentheses, you will find that, okay, we have something plus something times something plus something. That may remind you of foiling. So let's FOIL. We have not A, not A, B, A not B. Well, it's not B A, but same thing as A not B. And then not plus not B, B. Well, we know that something and not something is just false. This is false. This evaluates to false, and this also evaluates to false. So we're left with A not B, or not AB plus A not B. And if you know, okay, we have opposites on the farthest side, and they're not opposite in the inside. That's just A exclusive or B, and that's your answer. All right, I'm just gonna hit here.